In this video, we are going to discuss a new topic, that is combining Turing machines. In the simplest case, we can say that we can construct a composite Turing machine by executing first Turing machine and then by executing another Turing machine. Suppose you have two Turing machines in the form of T1 and T2. So we can create from these two Turing machine, we can create a composite Turing machine or a combined Turing machine, we can say. And this composite Turing machine can be addressing to the another problem. We can say that problem is concatenation of the original two problems. So imagine that T1 and T2 are two Turing machine, but they should have disjoint set of non-halting states. So we all know that there are two types of halting states in Turing machine. One is accepting states and another is rejecting state. So these states should be disjoint in nature for both the Turing machine. And let us imagine that both these Turing machines are having their own transition functions in the form of delta 1 and delta 2. So Turing machine T1 is having its own delta function delta 1 and T2 Turing machine is having its own delta function, that is delta 2. And there are these two machines are said to have disjoint set of non-halting states. Disjoint set of non-halting states. So in this scenario, we can say that T1, T2, this particular machine is denoting a composite Turing machine. It is denoting a composite Turing machine. Now, what would be the definition of this composite Turing machine? So in this composite Turing machine, the set of states will be basically union of the two sets of Turing machines T1 and T2 respectively, right? So T1 will have its own states and T2 will have its own states. So the union of these two states will be basically the set of states of the composite Turing machine T1, T2. Now T1 and T2 begins in the initial state of T1. Okay, so beginning of this composite Turing machine will be beginning at the initial state of the machine T1. Okay, and it basically first executes all the moves of T1 machine. So for executing those moves, delta 1 will be utilized. Okay, delta 1 will be used for executing all the moves of machine T1. Okay, and this will be going on up to the point where T1 would halt, right? So all the delta 1 will be utilized until all the symbols are getting processed until the T1 is going for a halting state, right? So this halting state in would be a rejecting string also and an accepting string also, right? So for any move that would cause the Turing machine T1 to halt in accepting state, this move further has to be extended to Turing machine T2 in order to create the composite Turing machine, right? So if my Turing machine is, say, it is halting in a rejecting state, so I am not bothered about those transitions to take forward for composite Turing machine, right? So the only transitions, the only moves that would cause my Turing machine T1 to halt in the accepting state, this composite Turing machine T1, T2 executes the same move, except that the move, instead of halting to the accepting state, it will go now to the initial state of second Turing machine, that is T2. So wherever it was halting and it was halting in terms of the accepting state, now it will not halt in that accepting state, rather it will further lead to the initial state of Turing machine T2, and that is how we are going to create a connect between the Turing machine T1 to Turing machine T2. Now at this point, the tape head will basically be positioned at the square on which the T1 is halted, right? And from this point onwards, the moves of T1 and T2 are the moves of T2. So once you are entering into the initial state of T2, further the delta 2 will be used for executing the moves of T2 under the composite Turing machine T1 and T2. Now, if either T1 or T2 would reject during this process, T1, T2 will also do the same and it will reject, right? So T1, T2 accepts precisely if T1 is getting accepted and when T2 is also getting accepted, right? So T1 acceptance will make it to go to initial state of T2, and if T2 accepts, then only we can say that the composite Turing machine T1, T2 is also accepting a particular string. Now, in order to use this composite Turing machine in a larger context, we would construct a transition diagram which will be showing T1 followed by T2. So we can mathematically note it down as say T1 or T2. Further, we can also make the composition conditional, right? So depending upon the current tape symbol, if T1 is halting, then we may further write that T1 is going to T2 based on certain tape symbol, that is say A. Okay, so we can also write these kind of conditional compositions wherein we are trying to indicate how my machine is transiting from T1 part to T2 part, right? So this composite Turing machine can be used in order to solve larger context problems also, right? So the composite Turing machine T1, if it is rejecting or if it is looping, in that case we also say that it will never lead to T2 Turing machine, and all those strings will not be also part of the combined Turing machine or composite Turing machine. So this sounds very similar concept to that of what we have seen as concatenation of the finite automatons, right? So it is a similar concept wherein this is can be treated as a concatenation of two Turing machines.